Right, question 1, 2015 on sets. So this is continuing on from the other sets questions we've been doing for the last few classes. Okay, so again, a three circle Venn diagram. The sets A, B, and C are as follows. A is equal to 1, 2, 3, 5, 6, 7. B is 2, 3, 4, 5, 8, 9. C 1, 4, 5, and 10. Complete the Venn diagram below. So as we were saying in the last class, you really do start in the center, just like a flower, and you branch out. Okay, and it's because this center bud here has to be subtracted from all of the other regions. That's why you need this piece in the middle first. Okay, so what is that little piece in the middle? Well, that is the point where A, B, and C intersect. Okay, or in other words, it is the elements that they have in common. So when I look across here, I'm trying to see, is there any number that belongs in set A, set B, and set C? Okay, because that circle, that little piece in the middle, that bud in the middle, is where the three, and it's the only place where the three of those circles overlap. Okay, so I see one here and one here, but no one, so it's not one. There's 2, 2, no 2 there. Excuse me, it's not 2. There's 3 and 3, no 3 there, it's not 3. 5, 5, and 5, look at him. So there's a 5. A 5 and a 5. So that 5 goes into the center there. Okay. I see a 6, no 6 here. I see a 7, no 7 here. Okay. And then I don't need to do any more because they're not going to be in A. I've checked all the numbers in A. So 5 is the only number that A, B, and C have in common. So you can see I've marked it off the sets because I've now filled it into the Venn diagram. And then the next place you do are these ones, okay? And these ones are where two circles overlap with each other. So this one is where A and B is overlapping. This one is A and C overlapping, and this one B and C, okay? But we'll take this one, for example. You can see that the set A doesn't belong to this area here, okay? So we'll stick with this one. Is there any numbers in B that B and C have in common that are not in A? So let's have a look at B and C. I see 2, I see 1, I see 3, 4. Look at 4. Let's mark off 4. Okay, and let's put a 4 in there. And 8, 9, and 10, no. Okay, so 4 is the only number that B and C have in common that's not in A, okay? Now, note that they have, this is what B and C actually have in common, okay? So if I can complete these circles, can you see they have both 4 and 5 in common? The difference between the two areas is that 5 is also in A, whereas 4 isn't. So that's what that split line there in the middle means, okay? But if you ask me what have B and C got in common, and you don't mention A, then my answer is 4 and 5. Okay, let's have a look now at A and C. So I have the number 1. Yeah, that one's good. A and C. So out here, there's the number 1. The number 2. No. 3. No. 6. No. 7. No. Okay, so just the number 2. Okay, and now finally, let's have, or just the number 1. Let's have a look at A and B. I see the number 2 coming up to play. So there's 2. 3 as well. 6 and 7, 8 and 9. Okay. So I hope that makes sense, okay? And then any numbers then that's out here that I haven't used are in the area where what we call A only. So if you can see when I do this little piece of A, you can see none of the circle B is in it, and none of the circle C. So these numbers that are left are not in B, they're not in C, they are what we call in A only, okay? So out here they go. So the number 6 and the number 7. Okay, in B, I'm left with 8 and 9, and in C, I'm left with the number 10. Okay, there's no universal set in this one. Okay, so that's why there's no box around it here, and that's why there's no numbers here going on the outside. Okay, that's very unlike the one we did the last day, where we did have a universal set and we did have 3 sets. Okay, so that was the question 2, 2015 one. Okay, so that's the Venn diagram done, and there could be as much as 10 marks for the Venn diagram, so well worth your while knowing exactly how to do a Venn diagram. List the elements of the following sets. Okay, so little bits of sets language here. The log tables tries a little bit to help you out with sets language. Where is it? Here. Okay, it's on the same page where they do the types of numbers, but they at least tell you that that is intersection, this is union, this is less, okay, and so on and so forth. So just in case you mix up the symbols, have a little look here and see does it help you out. So this is a union B, okay, and some teachers talk about the union of marriage and bringing everything together. So that is all of A joined together with all of B. Okay, so be careful because it's not just 6, 7, 2, 3, 8, 9, for example. You have to include all of A, so you'll see me drawing a circle around it, and all of B. Okay, so you can see it's everything basically apart from 10. So it's up to you then whether you list the numbers from the Venn diagram or list them from here. It's up to yourself, okay? But a couple of rules. You must have the squiggly brackets at the start and the end. The numbers must be in numerical order. So I'm going to start with the number 1. Okay. And sometimes I find it easier to do it from here, which is why I tried to not scribble the numbers out where I could, but just literally mark them out nice and easy. Okay. So number 1. Number 2 comes next. Okay. Do you see the way it appears twice? You only write it down once though. 3, comma, and you must have a comma between each element. 4, comma, 5, comma, 6, comma, 7, comma, 8, comma, 9, and close your squiggly bracket. So what I do then is I count the number of elements. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I'm confident then that I have them all. So that's A union B. A slash C. What does that mean? Well, A difference or less. Okay, so A less C or A not C. Okay, so what I do with my hand, okay, so imagine me covering my hand all over C. Okay, so that's covered now with the palm of my hand here on my screen, okay, because it's not C. So what is left in A then? Okay, so can you see it's 2, 3, 6, and 7. And actually physically cover C and it's much easier to see it, okay? Let me do that again. So cover C with your hand, and of course B has nothing to do with it, okay? It's the circle A less C. So 2, 3, 6, 7. Again, squiggly brackets, commas between them. And then it says A union B intersection C, okay? So just like BOMDAS, you do what's in brackets first, okay? So B intersection C. So B intersection C, okay? Where do they intersect? Okay, so that N here is an intersection. So this is where they intersect. So not just 4, it's 4 and 5, okay? So I tend to do this, where I do 4 and 5 just under that, okay? So again, just to show you, there's B, there's C, and there's 4, comma 5, okay? And then union it with A. So in other words, join that to A. And A is 1, 2, 3, 5, 6, 7, okay? So insert the 4 and 5 in here in numerical order. Okay, so you're going to get, and you can do it like this if you want, 1, 2, 3, 5, 6, and 7. Okay, and by doing that, you're actually showing the examiner, I do know what is A, I do know what's B intersection C. So therefore, if you make a mistake like all us humans do, 4, and I'm just writing down 5 ones, 6 and 7. Okay, so again, a count 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so we're good. Okay, and then the last part, complete the following identity. So this comes up in higher level, junior cert. Any of this could come up in ordinary level. This comes up in ordinary level. This comes up in higher level. Complete the following identity. Okay, and there's a section in your book on this. I've just literally pasted in that section here just to go through it. Okay, and it's what's called the associative and distributive properties of sets. Okay, so these are there in addition and multiplication and stuff. I suppose we just do them without knowing what we're doing. So in other words, addition, you can go A plus B and then you can add C to it. And it's the same thing as if you added B and C first and then added A to it. We do this without even thinking about it. Okay, so these are associative properties. Multiplication is the same way. It doesn't matter what order you multiply 2 by 3 by 4 in. You're going to get the same answers. If you do 4 3s are 12 and multiply by 2, you're going to get 24. If you do 2 3s are 6 and you multiply by 4, you're going to get 24. Okay, so that works for addition and multiplication. Okay, distributive property then of multiplication over addition, what happens when you join them together? So if you've got A multiplied by B, B plus C, okay, let me again give a numerical example for this because sometimes it can be easier to see. So if I go 2 multiplied by 3 plus 4, okay, what it's saying is that is the same. So you know I could go 3 4s, 4, 5, 6, 7 by 2. So that's 14, okay. What it's saying is it's the same thing as if you go 2 by 3, okay, and then you go 2 by 4. Now you do this with algebra all the time, okay, when we do brackets and we have x's on the outside, but you don't realize what you're doing, okay. I hope you can see that. Okay, 2 3s are 6 in this one, 4 2s are 8, 8 and 6 is 14. Okay, so these are what's called the associative and distributive properties of addition, and they also work over sets. Okay, so I suppose the easiest way I have of remembering them is exactly like what I just did here. Okay, I kind of multiply out the brackets in my head. Okay, so what do I mean by that? Okay, well, let me do the associative ones first. So this tells you that if you do A union B and then you union it with C, it would be the same as if you did B union C and unioned it with A. Okay, I always think these ones are a little bit easier to understand. And the same with the intersections, it doesn't matter which ones I look at first. So in other words, if I was unioning them together, I can start at C and then add in A and B, or I could start at B and add in A and C. It doesn't really matter. Okay, so the order doesn't matter. Right, the distributive ones then, okay, where they mix multiplication and addition. To me, it's just like you multiply out the brackets. So if you have A union B intersection C, it's the same as A union B. So I'm multiplying them together and I get this bracket. And then you intersect it with A union C. Okay, so to me, that is very similar to 10 times 4 plus 3, okay? 10 multiplied by 4 plus 3, it'd be the same as 10 multiplied by 4 plus 10 multiplied by 3. Okay, that is all this is telling you. And then you can also do it for the intersections. Again, multiply out the bracket. A intersection B union C is the same as A intersection B unioned with A intersection C. Okay, so have a look at that in your book. You'll see a section in every book on this in the higher level sets section. Okay, so how do we work this one out? So this is how the question comes up. It's exactly like this, okay? And this is how they asked it in 2015. Complete the following identity. A union B intersection C could also be written as A union B, okay, intersecting with, and then they asked you to fill in the last bracket, okay? So it's A union C that goes in there. Okay, so I hope that makes sense. And that was that question.